Welcome, everybody. My name is Luciano Oliveira. I'm the head of the Phoenix office with Stratless Consulting, and this is the future of tailings dam monitoring, an integrated system approach. This presentation provides inputs in how to make choices around integrated systems that can improve risk monitoring at tailings dams. Uh, As we get started, a little bit about Stratalys. We are a strategy and innovation consulting firm. We help companies evaluate and adopt different technologies. And we actually work with many industrial clients. And in the mining world, we work with most of the top five global companies. The motivation for this work, looking at the report of the Brumadinho accident, is the understanding that the complex situations demand more robust solutions. Um, by analyzing the report, it's very clear that it was a very complex failure. So actually, the company operating the facility had access to most of the very modern monitoring devices, but they faced a situation where multiple factors combined and led to a situation where these uncertainties um, resulted in an unsafe situation that was not captured in their existing systems. In the report, they used the data to make a simulation of the conditions leading to the accident. And one of the very interesting conclusions is if there was a detailed simulation in place at that time, it was possible to actually see that the situation was not safe, and perhaps some action could have been taken as a result of analyzing a more complex model. So the question that I put to myself and my team was, can you use this learning to maybe design this system not as a forensic tool, but as a tool for day-to-day monitoring, and perhaps prevent some of these accidents from happening in the future? So that was the motivation leading to the research. Well, we started by analyzing actually hundreds of solutions available in the market, especially in the tailings environment and broader mining. Um, there is actually a lot of different tools. Some of them a little bit overlapping in what they do. Some are very narrow in functionality, some very wide. So it's a very complex ecosystem. Uh, then I said, well, historically, tailings has not been the major focus of investment for these companies. So perhaps companies that do monitoring systems have even more advanced systems that are employed in other industries. And that's exactly what we did. We look at other industries like the military, construction, oil and gas, and even within mining, at mining exploration. And we look at approaches, tools, techniques that could be used as inspiration to really improve what was being done in tailings. In order to do that, we talked to very unusual entities. Um, so companies in the world of technology like Google and Uber, uh, entities like the National Oceanic and Atmospheric Administration. So if they're able to forecast the weather with some precision, there is something that we can learn from them. And DARPA and the U.S. Cyber Command and other high-profile entities in the defense world that actually invest a lot in getting monitoring technologies that are best of class. Well, some of our conclusions was that we should look at these different technologies according to a value chain. So it all starts with acquiring the data. Then you have different new technologies that can be used for that. We look at things like advanced sensors, um, augmented reality, non-invasive tomography techniques that give you a better understanding of the soil conditions, and a lot of techniques involving large-scale imaging, usually with drones or satellites. Next step is to collect this data to a digital platform. So there's a number of solutions involving connectivity, the ability to retrieve the data from the field and bring this data into servers where they can be and analyzed without requiring boots on the ground. Um, we looked into some interesting techniques to index the data, so it becomes possible to overlay data coming from different sensor types, and also database solutions that allow the storage and retrieval of information from just one single source of truth. So there is no confusion about what is the most updated data or if the data is valid or not. Um, also looking into different techniques for data analysis and interpretation, including solutions like very realistic modeling techniques that result in what's called digital twins, and also stochastic modeling techniques that try to deal with uncertainty and minimize those variations. There is also new technologies that allow the identification of exceptions and insight in a broader sense. They usually require a data lake and the analysis of patterns in a broad set of multivariate data. Um, a number of tools related to machine learning and artificial intelligence, and also predictive models that allow advanced simulation and extrapolation of behaviors into future conditions. And finally, all this data analysis should result into a determination of a safe condition or condition that may pose concern. And there are ways to automate the notification of potential alerts and triggers, and allow the qualified people to make decisions without delay. Um, some of these capabilities are organized as remote operating centers, and also some of these tools allow remote and virtual collaboration of teams that may not necessarily sit on the site. Um, these solutions actually require an integrated architecture, and that's one of the big findings. So you have different sensors that will feed into the system. You have a portion of the system that will harmonize and integrate and allow you to seamlessly evaluate data coming from different sources. Um, you should have the ability to analyze and model the data in the platform. And for that, 3D and 2D models that allow to see a cross section of or the entire site are becoming more and more prevalent. Uh, Also advanced analytics, so the ability to do dynamic analysis, simulation, predictive models, and this is one area that uh, today is, I would say, very much underexplored in many sites and companies. And finally, this integrated platform should have the the ability to display the data in a dashboard so it can be visualized and geotechnical people can make conclusions based on what they see, and also the ability to generate reports and notifications. Um, this system is, of course, not likely to be implemented all in a big bang, but what we believe is that there will be a path uh, of progressive functionalities and across two main dimensions. One is really having better quality data. So going from static data, so data that you load um, most of the times manually just once, to a situation where you have a real time data that is used to calibrate your analysis and outcomes. And the other dimension is increase the modeling complexity from qualitative analysis and the risk trees that you have today to models that will apply advanced AI and neural networks algorithms. We see four distinct stages. The first is semi-automated monitoring, where the focus is pretty much on automating the acquisition of the data, so avoiding the need for sending technicians on the field just to retrieve the data. That involves installing Wi-Fi connectivity and IoT devices, data loggers most of the time. Then things evolve to what we call connected monitoring situation. When you start to see dashboards, you start to see data integration, you are able to consolidate inputs all in one place, but you're still looking pretty much at a raw data. You're still, in many cases, questioning the quality of the data. So there's still not a lot of automation in the analysis itself. What is really the focus of the next step? When you have more advanced analytical tools, then we're able to actually um, provide more inputs for judgment and decision making based on things like digital twins and 3D models. And the final stage of the evolution is when you have robust data lakes and use internal and external data effectively, and you use technologies like AI to understand patterns and really complement the human judgment with the machine power to analyze the data and predict potential behaviors. If we look at how the system would look like in the long run and all the elements that would comprise an advanced system, you would have different types of inputs, including detailed characterization data that really provide a realistic view of the site conditions, connected sensors, um, online APIs. So we would have, for instance, real-time hyperlocal weather forecasts, and it would have even other external databases with lab information and other benchmarking information. That architecture makes use of a centralized database. It is one source of truth. Advanced modeling techniques, machine learning algorithms, um, and also most likely at this point we would have this system running 24/7. So it makes sense to consider centralized monitoring. So any anomaly can be dealt with in real time. The outputs, so what it enables is, of course, a real-time risk assessment. In many cases, it could be to some degree quantitative, notification alerts, automatic generation of reports, triggering of emergency routines, and a real-time feedback loop that keeps the model um, close to reality automatically. So there are, of course, challenges in implementing such an advanced architecture. Um, Perhaps the first of them is really only technology readiness. So a lot of the most advanced technologies that allow, for instance, detailed data acquisition and characterization are quite new. So it's still a challenge to get all these technologies available and in commercial stage and ready to be implemented in the tailings specific application. The other point is reliability and user acceptance. New technologies typically have really poor reliability, and in many cases, um, practitioners consider the potential benefit and the pain of using the new technology and just make a decision to stay with what is reliable and available. So that's another barrier. Um, the other barrier is what we call non-traditional business cases. So some of these technologies can be quite expensive, and the benefit in risk reduction and safety improvement is quite difficult to quantify. So unless there is a very clear strategic direction towards doing the most you can to improve the risk profile, it's kind of difficult to justify some of the most advanced technologies. And finally, there is a cultural and skill gap situations. Um, some of the most advanced analytics require a level of knowledge and familiarity with the tools that still don't exist since this is a new technology. So getting people trained and getting people in a position to accept the change is typically also a factor to be considered. Well, companies considering embarking on this transformation journey, they need to think about both the technology changes and also how to implement changes in the ecosystem and partnerships. So, um, in many cases, it's very difficult to implement all these capabilities as a standalone company. So, we actually need to um, bring consultants, bring vendors, bring integrators to participate in the solution and participate in ways that might be different from the way they engage today. In some cases, it's outsourcing. In some cases, it's um, just operation of some parts of the processes. And that's something that a lot of companies are not used to yet. So that's another challenge to be considered. I hope this presentation was useful. If you want to know more, please feel free to contact me. Here are my contacts, and thank you.